Namaskar, friends. My name is Gautam Kumar Maiti. I have recently retired from Technip Energies Limited as a Deputy Chief Manager. I was working with them at various mega projects as EPC as well as EPCM. My total working experience is 37 years. And I'm basically a mechanical engineer having various NDD qualifications including a level 3 in RT from IRCA. I have also a IRCA certified QMS lead auditor, and from PCQI I am a practitioner. PCQI means Chartered Quality Institute, London. I have also experienced working in a fertilizer plant for more than 12 years. And since beginning of my career, I am with QAQC. This is my first presentation to any social media, and my subject is calibrations. I have seen lots of ifs and buts, lots of lacuna, lots of NCs, while people ignorantly or knowingly following the things. People does not use their knowledge, though they know what is right, what is wrong. They always try to take deviations. And calibration is a subject. It is very much important for any project, any research institute, any manufacturing unit, wherever it works. It's a very essential parameters. People, when we come to the constructions, first let me start with the civil, how they behave regarding this. Civil, the first criteria of having a civil using two instruments. One is theodolite, another is total stations. When you ask, please show the calibration certificate of theodolite and total station. First reaction is, no, there is no institute who can do these calibrations of these total stations and theodolite. In place of that, what they show is the factory made certificate, who is a manufacturer of those instruments. When objected, this is not acceptable, they started arguing. Yes, friends, I do believe arguing is a good thing. I believe that either you convince me or I'll convince you. When I ask to produce the proof, there is no laboratory available who can do these calibrations of theodolite and total stations. They show me so many things, but when I show, if you go to the list of NABL accredited lab, you'll find the lab available who does these calibrations. I have experienced people are forging the certificate. Yes, friends, people are forging the calibration certificate. When we inquire, when we go to the, or when we review the certificate, we find it is forged certificate. People trying to do some malpractice. Even the calibrator, there are calibrators or calibration agency who doesn't know how should be a calibration certificate. So these urge me to prepare these presentations in interest of the Indian project. Calibrations, suppose you are measuring some electrical parameters and your instrument is giving a wrong data, you might land into a problem of electrical shocks. You are measuring, or you are measuring some temperatures, and your temperature measurement machine is giving non-accurate data, which may lead to a fatal failure. Friends, that's why I must say calibration is a process. We should first understand how it should be and how it will be treated. In any research institute, if a parameter, your calibration instrument, or rather any instrument is not calibrated properly, you will be in a problem. Your result will be in other directions. Suppose you are asking somebody, give a 20 centimeter rod of 10 numbers, and the calibration, the instrument, vernier or scale, which is not calibrated properly by the vendor, so you will not get exactly 20 centimeter rod. You are going to market buying some vegetables and the weighing machine is not calibrated properly. So you might lose getting less weight vegetables and you are paying more money for the vegetables. So there are n number of cases I have seen that calibrations people are taking it seriously. Even big PMC, yes, I am talking with responsibility that there are certain people who knows what is calibration. In spite of that, they try to take the deviation from the subject. They always try to take shortcuts. So friends, these presentations is on calibrations. So let me start with my main presentations, calibration and awareness. Thank you. Friends, let me start with my presentations, calibrations and awareness. As a culture, before start of any presentation, we show a core values. To me, core value is today's quality and tomorrow's safety. I do believe one famous quote made by great philosopher Aristotle, that is, quality is not an act, it's a habit. Perhaps you people know who was Aristotle. He was the teacher of the great Greek leader Alexander. Now, what is calibration? If you say in a single sentence, it is purely a comparison between a calibrated instrument and the instrument you want to use. And these calibrations, new concept has come is uncertainty. So, what we can say? It's a comparison of measurement values of device under test with a calibration standard device with a known accuracy. As per International Bureau of Weight and Measures, it is operation that under specified condition, in the first step, establish a relation between the quantity values with measurement uncertainties provided by measurement standards and corresponding indication with associated measurement. Uncertainties is that of the calibrated instrument or the secondary standard, and in a second step use this information to establish a relation for obtaining a measurement result from an indications. It means when you are calibrating your equipment or instrument, there is a probability of certain uncertainty and it might be respect to your instrument as well as the instrument from where you are getting calibrated. The equipment used as a reference should itself be directly traceable to equipment that is calibrated according to ISO IEC 17025. Now, question is, why we require calibrations? Let me give you one example. Suppose you have went to a market and you want to buy say certain amount of vegetables. Now, the weight that is being used by the seller is not calibrated or outdated. You are asking a 1 kg of vegetables, instead of you might getting less or more vegetables. So, where the calibrations plays a role. Now, why we require calibration? Instrument calibration keep process safe. When measuring any parameter such as force, electric current, it is important that the quantities being measured are accurate to maintain product safety. Machine calibration can help to reduce cost from manufacturing errors. Suppose you have a scale or a vernier which is not calibrated properly, so your finished product might be giving a wrong result. So, your finished product might be get failed in inspection. Calibrations maintains certifications. That means once everything is calibrated, your certifications for that particular machine will be done according to ISO IEC 17025. Every device used for process critical measurement should be checked periodically to verify it continues to deliver the required accuracy, right measurement. Where adjustment is possible, a device measuring outside the expected limit should be brought back to the acceptable performance. That means, suppose your calibrations, where you are doing the calibrations, it is giving beyond acceptable limit, so it required a recalibration. But in case of non-adjustable equipment, the deviation or the measurement performance should be recorded and decision made whether it remains fit for purpose or it should be rejected. Calibration is important because it helps ensure accurate measurement. Accurate measurement are foundational to the quality, safety and innovation of most products and services we rely on every day. Few people realize the critical role and importance of calibration in their daily lives, but calibration improves assurance of precise measurement requirement. Why is calibration important? As I given you an example, another example, suppose you are flying abroad, carrying just allowed luggage, but at airport check-in counter declare it exceed by 5 kg and per kg cost, excess luggage cost is $100. Is it a joke for you? Upon investigation, it is found the calibration due date is over of the weighing machine, hence calibration is required. Suppose you are measuring some electrical parameters, risks of electrical shocks for those handling improperly calibrated equipment, especially in a hazardous work zone where electricity is present. If you do not calibrate temperature controlling or sensing device, you will not able to regulate the temperature of the facility, causing damage of your items. Suppose you are doing PWST and your PWST machine, the temperature it is showing by the calibrated machine, it is wrong. Instead of 650 degrees centigrade, it is showing 705 degrees centigrade. That means it is your whatever the PWC is doing, it is not right. So, ultimate metallurgical parameter may be a detrimental. So, here calibrations plays an important role. Another example, suppose you want to buy a furniture and which is supposed to be fit in a specific spot in your modular kitchen, but when you put the furniture, it seems it's like that it's a big for the area. It makes you wonder the dimension were taken correctly or not, or the piece of the furniture were measured correctly. Whose loss is this? It is your loss. So, conclusions, what we can say? Calibration is needed to help us confirm that the measurement we perform are being done with accurate devices. So, in our daily life even, calibration is a essential items. Now, questions comes, how do we calibrate? There are two parts in my presentations. At these presentations, I will simply tell you what is master calibrator, what is traceability, what is uncertainty. In my next presentations, I will elaborate how to issue a calibration certificate, how to check a calibration certificate. Now, come to this master calibrator. What is master calibrator? Master calibrator is that equipment or items from which reference you are measuring your instrument or you are measuring your equipment. So, these master calibrated are traceable to a national standards or international standards, and it is having a valid certificates. So, marking and the quality certification of goods for matters connected there with or incidental thereto. That means, whenever you are doing a calibration of your instrument, it should be traceable to a master calibrator, and master calibrator shall be traceable to a national or international standard. Master calibrator standard definitions like length. In 1960, length of the meter was defined as the distance between two lines on a specific platinum iridium bar stored under control condition in France. But in October 1993, the meter was redefined as the distance traveled by light in a vacuum during a time of 1/299,792,458 seconds. So, it is the international standard for measuring a length. Like this, there is a standard for mass in 1960. Before 1960, the standard time was defined in terms of mean solar day for the year 1900. A solar day is the time interval between a successive appearance of the sun at the highest point it reaches in the sky each day. The second was defined as 1/60 into 1/60 into 1/34 of a mean solar day. The rotation of the earth is now known is very slightly with time. However, and therefore, this motion is not good one to use of defining the time standard. Now, the second is now defined as 9,192,631,770 times the period of vibration of radiation from a cesium atom. All the above units are US customary systems which we used to follow. What is calibration report? Now, question is, people are not interpreting or people not issuing a calibration report as per norms. I have seen people are forging the reports, people are duplicating the reports. So, to check whether your report is right or wrong, you have to be very careful. A calibration report, also known as calibration certificate, is an important document containing essential information regarding equipment, calibration and condition. Yes, condition during calibration is a prime criteria. It is mainly used to report result of calibration. A calibration report should include details on out of tolerance conditions along with any special measurement conditions if it is required. It should refer the master calibrator reports details. It should reflect these condition, the weather condition of the particular measurement area. For me, the major factors for calibrations are three. That is traceability, uncertainty and tolerance. You have to check when you viewing or reviewing the calibration certificate these three parameters very precisely. Now, what is traceability? As I said, there is a master calibrator. Then traceability refers to the value of the standard where it can be related to the standard reference, national or international standards through an unbroken chain of comparison, all having stated uncertainties. Means when you were measuring your instrument or calibrating your instrument through a master calibrator, that master calibrator should be traceable to any national or international standard, and that should have a valid stated uncertainties. I will come how it we can calculate the uncertainties. Now, traceability in terms of kilogram, the kilogram is the unit mass, it is equal to the mass of the international prototype of the kilogram. Like that, meter is the length of the path traveled by a light vacuum during the interval of 1 upon 299792458 of a second, and second is the duration of 91926317770 periods of the radiation corresponding to the transition between two hyperfine levels of the ground state of the cesium-137 atoms. So, this is for the information only. We have to check the traceability in terms of your master calibrator, it has been written properly in your calibration certificate or not. Now, uncertainty. Uncertainty of measurement is a doubt that exists about the result of any measurement. For the statement expressed as 95% confidence level using certain coverage factor, this is how report is uncertainty. That means, whenever you doing a measurement, if you do a measurement of 100 measurement, then your confidence level should be 95 of them would be accurate within the stated uncertainty. So, 95% confidence level means whenever any measurement you are doing, out of that measurement 95% is accurate. We might say length of a certain stick measured 20 centimeter plus or minus 1 centimeter at 95% confidence level. This result could be written as 20 centimeter plus minus 1 centimeter at level of confidence of 95%. That means, if you measure a stick of 20 centimeters 100 times, 95 times it will give an accurate result. That is the uncertainty at 95% confidence level. Now, another factor comes into the picture which is called standard deviations. It is really convenient to calculate standard deviation by hand with pen and paper alone, but it can be done as follows. Suppose you have set up n readings, let us say we have 10 readings 16, 19, 18, 16, 17, 19, 20, 15, 17 and 13. The average is 17. Now find the difference between each reading and the average. Now our average is 17, with the first reading 16 it is minus 1, second reading it is plus 2, third reading plus 1, like so on, and the last reading it is minus 4. Now we square each of them. So, minus 1 become 1, 2 become 4 and last reading 4 becomes 60. Now, total divided this total reading, this 1 plus 4 plus 1 plus that is divided by n minus 1. In this case 10 reading, so we will divide by 9, that is 1 plus 4 plus 1 plus last 16, it is equal to 40. Now, 40 divided by 9 equal to 4.4. So, estimated standard deviation is found taking the square root of the total, that is 4.44 equal to 2.1. It is the standard deviation. Now, more readings you will take, a better, it will have less uncertainty in case of estimated readings. That will definitely improve your uncertainty measurements. In ordinary situation, at least 10 reading we should take. Next, I would like to show you how to calculate uncertainty. It is a formula, uncertainty is mu, it is root over of sigma by the reading in the data set minus mu by 2 divided by n into n minus 1. This is the formula for the uncertainty. Now, you have xi equal to jth the reading in the data set. Suppose you have a steel plate whose readings were taken by 5 different persons, and readings are 15.33 meters, 15.21 meters, 15.31 meters, 15.25 meters and 15.35 meters. Now, how to calculate this uncertainty of this reading? Mu, the mean of the data set, means sum of all 5 readings divided by 5, that is 15.29. Now, n is the number of readings. Now, x I minus mu, that is 0.04 minus 0.08, 0.02 minus 0.04 and then 0.06. Now, these figures, if we square root, if we square them, it comes 0.0016 and the last reading is 0.0036. It is then figure is coming 0.0136. What is that? X minus mu. Now, the square root of the reading, that is 0.0136 divided by 5 into 4 is equal to 0.026, and if we do the square root, it is 0.03. So, uncertainty is 0.03 meter. So, whatever reading you have taken, say 15.33, it might be 15.30, might be 15.36. So, this is how we can ourselves check this uncertainty, whether the calibrator, whether the laboratory who has given this calibration certificate has rightly calculated this uncertainty or not. Friends, this is very much required to know the uncertainty, because your all readings becomes very vulnerable with this uncertainty, especially when you are doing the instrumentation job. This uncertainty plays a big role. Otherwise, whenever you start the plant with these most critical items, uncertainty, if you do not know, then your parameter for process operations will be in trouble. You might land in a different trouble. So, friends, this calibrations is a very essential things for any project. I request everybody, whenever you check a measurement of any equipment, please make sure this equipment having a valid calibration certificate. This is all for today's presentations. Thank you. You may write to me at my mail ID maitizk@yahoo.co.in for any questions on calibrations.